Part 2 of the study of rational functions is going to move on to other kinds of asymptotes. Now, I have a nickname for asymptotes. This is not a mathematical nickname. It is just my nickname. I call them snuggle lines. A vertical asymptote, as x approaches a vertical asymptote, the graph will either approach positive infinity or approach negative infinity as it snuggles up to the line. Now we're going to talk about horizontal asymptotes. The definition of a horizontal asymptote. Horizontal, the line y equals b. Y equals a constant is a horizontal line. It is a horizontal asymptote of the function if f of x approaches b as x increases or decreases without bound. So, in other words, as x approaches positive infinity or x approaches negative infinity, the graph snuggles to a particular horizontal line. Here's an example. If this represents the horizontal asymptote, here's the function. As x gets bigger and bigger and bigger toward positive infinity, the graph snuggles toward that horizontal line. It could do it from above. Now here's something that's a little different in the study of horizontal asymptotes as opposed to vertical. Vertical asymptotes, the graph can never, ever cross the asymptote. The graph can cross a horizontal asymptote, but it is a horizontal asymptote if either going this way or going this way, the graph begins to snuggle to the horizontal line. All right, now to locate them. To find the equations of these horizontal lines, we use the degrees of the numerator and the denominator function. Now, your book uses n and m. I'm going to change that up just a little bit. I am going to say if you have f of x is equal to p of x over q of x, and n for numerator, n is the degree of the top, and d is the degree of the denominator. If n is less than d, then you have y equals 0 as the horizontal asymptote, abbreviated HA. If the degree on top is equal to the degree on bottom, then you get the line y is equal to, I'm going to use some other abbreviations, leading coefficient over leading coefficient. I'll talk about that in a minute. But if the degrees on the top and the bottom are the same, take the leading coefficient over the leading coefficient. It still will be a constant. Finally, if the degree on top of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. There may be something else, and we'll talk about that toward the end of the lesson. All right, number 10. Find the horizontal asymptote, if any, of the graph. All right, what I want to do is write down the degree of the numerator. Its degree is 1. Remember, the degree is determined by the exponent of the highest powered term. The denominator's degree, the degree is 2. This is a case where the degree of the numerator is less than the degree of the denominator. Therefore, you don't have to do any more calculations or study. The line y equals 0 is the horizontal asymptote, which, by the way, is the x-axis. That means the x-axis is the snuggle line. We put it all together toward the end of the lesson. All right, the next one, find the horizontal asymptote. All right, let's look at the degree of the numerator. N is 2, N for numerator. The degree of the denominator, D, is 2. When N equals D, I'm supposed to have the line y equals leading coefficient over leading coefficient. The leading coefficient of the numerator is 10. The leading coefficient of the denominator is 5. That reduces to 2. The horizontal asymptote is y equals 2. Sometimes this will be a fraction. Sometimes it will be negative. But it is leading coefficient over leading coefficient. Find the horizontal asymptote here. The degree of the numerator, which I've been calling n, is 3. The degree of the denominator is 2. Because n is greater than d, there is no horizontal asymptote. In a few minutes we may talk about, well, is there something else? Number 13. Find the horizontal asymptote. The degree of the numerator, which I've been calling n, is 1. The degree of the denominator, which I've been calling d, is 1. Because n equals d, I get the horizontal line y equals leading coefficient over leading coefficient. It is -8 over 7. I can't reduce that. It is the line y equals -8 over 7. So before we go any further, let me just remind you, vertical asymptote is a vertical line, and it will be in the form x equals some number. The horizontal asymptote is a horizontal line, and it will be in the form y equals some number. You must always describe those as equations of vertical or horizontal lines. All right, this box gives us some ideas, but about graphing a rational function, we are lucky we will also use our graphers. Suppose we have p of x over q of x. You will want to reduce and make note of any hole. And I'm not sure we're going to have any with holes, but just in case. Number 1 is to check for symmetry. We did this back when we first started talking about functions. If f of negative x is the same as f of x, we get y-axis symmetry. If f of negative x is the same as negative f of x, we get origin symmetry. Actually, we will probably determine this by looking at the grapher. How do we find the y-intercept? Well, you can find f of 0, or you can do table x equals 0. X-intercepts, you're going to set the numerator equal to 0 and solve. Vertical asymptotes, denominator equal to 0. You will not be dealing with holes by the time you get to this point, because we're going to reduce it to lowest terms early in there. All right, horizontal asymptote, we work with degrees n and d. Now here it says to plot one point, but honestly we're probably going to at this point use the grapher. Depending on your calculator, you may have to go into what's called dot mode. All right, let's see what we can do with